Birds have been shown time and again to have advanced cognitive abilities. Ravens plan for the future, crows count and use tools, cockatoos open and pillage booby-trap garbage cans. Researchers have long debated about the relationship between avian and mammalian intelligences. One possibility is that intelligence in vertebrates animals with backbones, including mammals and birds, evolved once. It's hard to track down. A series of studies published in Science in February 2025 provides the best evidence yet that birds and mammals did not inherit the neural pathways that generate intelligence from a common ancestor. This suggests that vertebrate intelligence arose not once, but multiple times. The findings emerge in a world enraptured by artificial forms of intelligence. They could teach us something about how complex circuits in our own brains evolved. Perhaps most importantly, they could help us step away from the idea that the neocortex is organized into 6 layers of neurons which receive sensory information from other parts of the brain, process it, and send it out to regions that determine our behavior and reactions, rather than 8 layers. Birds have a century ago, Neurona Tomis suggested that much of bird behavior is reflexive and not driven by learning and decision-making. This implies that what a mammal can learn easily, a bird will never learn. In 1969, Carton wrote a very influential paper that completely changed the discussion in the field, said Maria Tosches, who studies vertebrate brain development at Columbia University. A few decades later, Lewis Puel, Carton, and Puels were giving completely different answers to this big question. Tosches said, one camp continued to compare the circuitry in adult vertebrate brains, the other focused on embryonic development. Researchers tracked cells in the pallions of chickens, mice, and geckos at various embryonic stages to timestamp when different types of neurons were generated and where they matured. They found that the mature circuits looked remarkably alike the circuits that composed the mammalian neocortex and the avian DVR developed at different times, in different orders, and in different regions of the brain. How we end up with similar circuitry was more flexible than I would have in the bird pallium. Neurons that start development in different regions can mature into the same type of neuron in the adult. This pushed against previous views, which held that distinct regions of the embryo must generate different types of neurons. In birds, there's a fantastic reorganization of the forebrain, Gunchukun said. Taken together, the studies provide the clearest evidence yet that birds and mammals independently evolved brain regions for intelligence is hard to define. There are no ideal steps toward it, and it doesn't have an optimal design, Tosches said. Innovations can happen throughout an animal's biology, whether in new genes and the regulation octopuses and squids, independently of mammals, evolved camera-like eyes. Birds, bats, and insects all took to the skies on their own. Ancient people in Egypt and South America independently built pyramids. Octopuses have been caught performing incredible feats such as escaping aquarium tanks. Such findings could eventually reveal shared features of various intelligences, Samba said. The way we think about using insights from evolution to improve AI is very anthropocentric. I would be really curious to see if we can build like artificial intelligence from a bird perspective, Kemping said.